Download this code and get free GPT-4o from codegive.com, link in the description below. The nqueens problem is a classic combinatorial problem that involves placing nqueens on an n times n chessboard so that no two queens threaten each other. This means that no two queens can be in the same row, column, or diagonal. Problem definition. Given an integer n, the goal is to determine all unique ways to place n queens on a chessboard such that no two queens can attack each other. Optimized solution concept. A backtracking approach is often used to solve the n queens problem. However, to optimize the solution, we can keep track of the columns that are already occupied by queens, the two diagonals, the slash and backslash diagonals, that are occupied. This allows us to quickly check if a queen can be placed in a particular row and column without needing to check the entire board. Steps to solve the n queens problem. 1. Initialize data structures, use sets to keep track of occupied columns and diagonals. 2. Backtracking function, recursively place queens row by row. 3. Base case, when all queens are placed, store the solution. 4. Pruning conditions, skip placing a queen in a column or diagonal that's already occupied. Python code example. Here's an optimized solution for the n queens problem using Python. Explanation of the code. 1. Solve _n queens, n, this is the main function to solve the n queens problem. It initializes the necessary data structures and calls the backtrack function. 2. Backtrack, row, a recursive function that attempts to place a queen in the current row. It checks each column to see if it's safe, not under attack from previously placed queens. 3. Data structures. Columns, a set that tracks which columns have queens. Diagonal 1, a set that tracks which /diagonals have queens. Diagonal 2, a set that tracks which /diagonals have queens. Board, a list that indicates the position of the queens on the board. 4. Adding and removing queens, when a queen is placed, the position is marked in the sets. If a recursive call returns, backtracking, the position is removed, allowing for the next iteration to explore different placements. 5. Print _solution, solutions, this function formats and prints the board configurations for each solution found. Complexity. The time complexity of this backtracking solution is O(n), which is the number of permutations of n queens, but the pruning helps significantly reduce the number of configurations that need to be checked. Conclusion. The n queens problem is a great introduction to backtracking algorithms. The solution provided optimizes the search space by using sets to track occupied positions efficiently. This allows for faster execution, especially for larger values of n.